All right, coming up here on the top of the hour, and looks like we have quite a few people who have been able to join. So let's go ahead and get started. Thank you for joining, everyone. My name is Ethan Rido. Today we're going to be talking about solutions to tool making shortages and talking specifically about 3D printing for tooling automation. Just a little bit of housekeeping before we jump in. The webinar is being recorded today, so you're going to receive a copy of the slides as well as a recording. So if you have to drop off early, don't worry about it. If you have any questions throughout the webinar, please use that Q&A function. I'll be monitoring that throughout the webinar, as well as at the end, I'll take some time to answer some questions. But if you have any sort of questions throughout the webinar, please use that Q&A function. But let's go ahead and jump in here. A quick agenda for today, lots to cover here in this quick 30 minutes. And thanks again for taking 30 minutes out of your day to spend with me. But we're going to look at some of the data around tool making, talking about labor challenges, lead times, cost of tooling, both domestically and foreign. We'll really dive into the data and see what that data means. I'll do a brief introduction to Mantle. The goal of today is not to cover in detail about Mantle, but really to talk specifically about metal 3D printing for labor challenges. We'll look at a bunch of different examples of how people are actually addressing this challenge with labor, addressing these labor challenges with metal 3D printing. Then, of course, I'll take questions and answers. But as I said, feel free to ask those questions throughout, and I can monitor that Q&A and answer those questions. First here, like I mentioned, we're going to dive into the data a little bit. And specifically where I pulled this data from is the MAP, the Manufacturing Association of Plastic Processors State of the Plastics Industry report. They do a great survey and report every year to their few hundred members, which are all plastic processors in the U.S. Bureau of Labor Statistics. And I pulled a couple of statistics and charts from The Economist, which you'll realize, which you'll see later on as well. If anyone wants to dive more into this data, I encourage you, and the raw data, I encourage you to email me, and I can go ahead and shoot you over the links to where I found this data and some of the raw data, which I've had a lot of fun exploring and playing a little bit of an economist, which is a little bit of a different role for me here today. But just to preface some of the data we're going to look at, when you see a decrease in supply and an increase in demand, this is really just economics 101 here. We're going to see an increase in the price of that good. We're going to see an increase in the lead time of that. And when I started to look at the data, I really wanted to frame things in this light of, are we seeing this decrease in supply? Are we seeing an increase in demand? Firstly, looking at a decrease in supply, and if I go ahead and look at the number of tool makers over the past 20 years, or 25 years roughly, there's a pretty clear decline in that from the U.S. Bureau of Labor Statistics. You can see that the amount of tool makers in the U.S. has declined by about 50% over the past 25 years. Every day when I'm talking to processors, mold makers, OEMs, et cetera, they're always telling us how difficult it is to hire tool makers and how worried they are about the tool makers they do have, because when they retire, you're not sure what they're going to do to replace them. Just want to make sure my camera's working. So pretty clear decline in the number of tool makers here in the US. Sorry about that. And as I was trying to tee up here, that's a pretty clear decrease in supply, both in the number of tool makers, and of course, this is going to have a direct correlation to the capacity of tool capacity that exists in this country. So there's our really decrease in supply, that's that tool maker shortage. But that would be okay if the demand was going down in parallel, because if there's less supply and there's less demand, that's no problem. But are we seeing an increase in demand also? And again, from this Manufacturing Association of Plastic Processors report, their processors are reporting the highest percentage of OEMs attempting to reshore in the past 18 years. With over 54% last year of OEMs reporting to plastic processors, they're attempting to bring molding and tooling back from abroad and bring that back to the US. So the demand is increasing, which is great for a great opportunity for domestic manufacturing and domestic tool making. And we're seeing that increase in demand. So when we combine this toolmaker shortage and this OEM reshoring effort, if the economics work, we should see an increase in tooling prices, and we should be seeing an increase in tooling lead time, because the shortage is happening of capacity and the demand is increasing. So is this happening? Does the theory hold up? And that's where we can dive into some more of this data of what processors are reporting in terms of costs and lead time. Processors, again, this is from the Manufacturing Association of Plastic Processors, are reporting in 2020, they reported a 57% reported an increase in domestic tooling lead time. That was an increase from 23% in 2017 and 2019, up to a 57% of all reporting a either significant or greatly significant increase in tooling lead time for domestic tooling. This isn't just happening here in the US, it's also happening with foreign tooling. The processors also reporting with actually quite a bit more significant jump, with 41% of processors reporting an increase in foreign tooling lead times on their tooling. Additionally, when we look at the costs, this is for domestic tooling, 80% of processors reported an increase or a significant increase in domestic tooling prices in 2023. So they're seeing lead times increase on domestic tooling. They're seeing costs increase on domestic tooling. This is not a new phenomenon. A lot of people have decided to build tools overseas and in Asia and in China to help them produce tools quickly and at lower cost. But what I'm hearing more and more of, and what I think a lot of us are hearing more and more of, is that the world is really evolving, and specifically in China, it's becoming not the low-cost country that it used to be, and that tooling costs and tooling lead times, specifically in China, are going significantly up. You can see here just a chart from The Economist of the manufacturing unit labor cost per hour, just how much that has increased over the past 30 years as China has matured, and that has correlated directly to tooling costs, tooling lead time. We hear a lot today that a lot of that tooling work has actually moved to some of these other low-cost countries like the Philippines, Malaysia, Thailand, India, Vietnam. But from what I hear, the quality is just quite a bit lower than what was coming out of China. So there isn't a direct solution there. So to back up that point as well, 53% of processors reported an increase or significant increase in foreign tooling prices in 2023 as well. You can see that here on the chart, that it's not just domestic tooling that's increasing, it's foreign tooling that's increasing as well in terms of price and in terms of lead. I quickly wanted to do just a quick poll here to the group to understand how concerned is your organization with labor, both hiring of, can be toolmakers, but hiring in general. I know even here at Mantle, hiring is one of the hardest things we do to find hardworking quality people, and just curious to do a quick poll here of the group. I probably could have skipped all of these slides that I just presented and just done this poll, because right off the bat, I'm seeing a lot of 4 and 5s, which really correlates with what we're hearing every day out in the field and anecdotally. But I like diving into some of the data here, so I thought that would be kind of fun to show. Yeah, seeing a lot of 4s, a lot of 5s, which is great, and that's why you're here, and it aligns really with what we're hearing and the challenges. Let me share these results. I think you're seeing the results now, but of about half the people that voted, no one was under a 2. A lot of 4s, some 5s, and a couple of 3s here. So you are not alone in this challenge, and there are solutions, which is what we're going to turn to now. Start to talk about what are some of the solutions to these labor challenges. And of course, Mantle is one of them. Just another piece of data that really speaks to this, but for every 1 person that enters the trades here in the US, 5 retire. This is from ISHN, and this is the US data. So this is not a problem that's unique to toolmaking, but really in this country in general. So we need to look for solutions. But of course, Mantle is one way to address this challenge for the toolmaking industry. Our goal at Mantle is to automate the toolmaking process by printing precision mold components that have really unmatched accuracy, surface, tool steel performance that allow you to eliminate a lot of the time and costs of operations like programming, rough milling, and EDM. Not just the time and cost, but also the amount of highly skilled labor required to do those steps. If we look at a conventional toolmaking process, there are lots of steps involved, and every single one of those steps requires highly skilled labor and someone who's an expert on these processes. It's very hard, and you're very lucky if you could find someone who knows how to do all of these steps, which is why there's often quite a few people involved in this process. The goal of Mantle, of course, is to remove as many of these steps as we can, and then of course it's going to vary per application, and we're going to look at some examples today where we remove all of the steps, some examples today where we remove only maybe through rough milling. We still have to do that. But the ideal scenario with Mantle is when you can take apart, you can print it at the push of a button, and all you have to do is a little bit of final finishing, grinding of the outside, finishing of your ejector pins, where you're going from hundreds of hours of work, maybe 10 hours of work to produce a highly precise mold. From here, we're going to jump into a bunch of examples of how people are actually doing this. I find that generally that's what people are most interested in. It's great to look at some of the data. It's great to look at our fancy printing technology. But what does this actually mean for people like you, for processors, for molders, for OEMs, for mold makers? We're going to look at just a bunch of examples of how people have done this. This is an example. I have one of the inserts here on my desk, a relatively small insert. The other piece is a little bit larger. This is actually an overmold for a dental application. Here they printed the core and cavity, as you're seeing on my screen here, and I have the core here in my hand. They did this at a 40% lead time reduction by printing it with mantle. This was printed in the H13 tool steel. They reduced the total operations time from 200 hours to 110 hours. So that was what was really critical and really pertains to this topic today, is that reduction in the amount of active labor hours from 200 to 110 hours. And most of that came from removing the amount of EDM that was required to build this tool traditionally. This was molding a 60% glass filled nylon, and it was over molding a piece of wire. To look at this tool, I always think it's interesting to show here, but of course, with printed tool seals, you can do any of the finishing work afterwards if you need to. You can see that they just overprinted some of these features, and then they came in and just did a final burn, but that was still a massive reduction from the amount of EDM time that was going to be required to build these tools, because rather than having to do 100 hours of EDM work, they just did a little bit of final finishing EDM in about 27 hours. So you can see the process here, how it compares to a traditional tool build versus with mantle, removing a lot of those steps. And common theme with mantle is the desire and the ability to remove or eliminate EDM steps. With mantle here, they took that EDM dramatically down to save 90 active hours for Fathom here, which is just a good first example. Another great example, a newer one from our customer General Pattern. They were producing this relatively large tool. It was for an automotive trim component, actually for a piece of siding for a truck. It required 31 hand picks. You're seeing one of them here on the screen. And the customer was looking, this was a prototyping application to produce these in 4 weeks. They needed to get plastic parts in their hand very quickly. To build this, the entire tool traditionally, they estimated would have taken them, or would have required 4 of their tool makers really full time for 4 weeks to produce this tool, because of all the different hand picks, as well as the traditional cores and cavities, the mold plates, and everything else that would be required to build this tool. What they did was they printed this tool with mantle, the tools with the hand picks with mantle. They actually used these as printed. They didn't do any finishing work to them. They took them right out of the furnace or out of the mantle process and put them right into the mold, which is pretty incredible. That we have heard of more and more people doing that recently, where traditionally we saw a lot of people doing grinding work and things afterwards. Here they used the tool as printed. It also featured this sort of knife edge, a very sharp edge component that would have otherwise required quite a lot of extensive EDM, which is why they chose this component to print with mantle. The key results here was that these hand picks only required 4 hours of active labor time from General Pattern's toolmakers, and that was actually mostly just running the machines, which are very simple and easy to. They estimated that mantle saved them about 200 hours of active toolmaker time for the hand picks per toolmaker. And since they were able to use mantle here, they, rather than using 4 toolmakers, they only had to dedicate 2 toolmakers to this project, which of course frees up those 2 toolmakers to work on other projects. They saved 2 toolmakers on this project, so they only had, rather than 4, they were able to use 2. Great quote here from Denny, who is the CEO of General Pattern. He says that with the simple press of a button with mantle, we can effortlessly create tools, which completely changes our ability to tackle labor challenges and enhances our capacity to better serve our customers. Recently, with a slide for a transportation trim component, this is the application we're talking about here. We skipped the finishing process entirely, printed it, assembled it into the mold, and immediately began molding parts. It's not only saved us hours of traditional toolmaker time, but also freed up my team to focus on other things. So just another good example of really saving a lot of active hours by using metal 3D printing and mantle to automate the process. Another example from General Pattern, this is actually a medical device application. The OEM was actually trying to move a project from overseas back to the US. They were only needing about 5,000 parts a year. They couldn't transfer the tool, unfortunately, from overseas, so they needed to invest in a new tool. And like everything in manufacturing, it seems like they had a very tight timeline and minimal budget to make this happen. They used mantle here to print the tooling. It was about a 5x5 insert that they printed that in just 5 days. It ran over the weekend, of course, so they were at home enjoying their weekend. The machine was back at the shop printing. They applied a light texture after printing, and they were done. They saved 3.5 weeks of lead time on this tool. Very minimal toolmaker time to produce the insert, only 4 active hours, met the budget expectations. What was really important to them was that because they were able to provide this to their customer, they won this bid, they won this production order, they won the business of this customer, which is helping them build a relationship with future projects as well. That may be a future webinar for us, but we're seeing a lot of people use mantle to win new business, to open business, and even if it's producing a prototype tool in 2 weeks to run 5,000 parts, they want to go ahead and win that $5 million, that 5 million part order. That's a future topic, a little bit off topic here, but was a great example for General Pattern of being able to win that production business because they were able to use Mantle and with very little. Moving over to another customer of ours, West Tech out here in California. They've invested in a Mantle machine really to help them free up their experienced toolmakers' time, focus on critical specialized steps like tool repair, finishing, and maintenance. Where they have a tool shop, but a lot of their tooling time is dedicated to repair and maintenance because their job is to keep their press running. They can produce production-ready mold cavities and cores, in some cases just days, as opposed to 10 to 12 weeks where they're mostly outsourcing their tooling, and now they have the ability to produce more tools in-house dramatically. Another great quote, I love quotes here, and I don't know if you're in the industry and I've met Tammy. Tammy's great, the president of West Tech Plastics, but she says that tooling is the base of our company. Without quality tooling, we can't produce quality parts. It's getting harder and harder to find quality toolmakers. Using Mantle's technology, we complete up to 70% of the job and have our toolmakers handle the specialized steps that only a human can do. We need to take advantage of this new technology with Mantle. We can provide our customers with a service they can't get anywhere else. Another quote I didn't include here is Tammy said at West Tech, they tried to hire a toolmaker for 1.5 years. They were not able to find anyone. And that's really where they started to look for solutions and eventually ended up with Mantle. A good use case from them is these medical manufacturing aids, relatively small inserts here. They printed these actually for one of their customers, Raycon. It took about 60 hours total, so about 2.5 days to print these two inserts together. Of course, that's fully unattended. Then they went into the furnace for 1.5 days. That was 5 days from design to ship H13 inserts. One thing I like to always emphasize about these tools is that they are not the most complex tools in the world. When I show these to people at trade shows, they say, "Oh, I could machine that in 8 hours." Oh, maybe you could, but for a lot of places, for a lot of tool shops, a lot of molders, they are at capacity. Their tool shops are slammed. They don't have an open machine. So investing in technology like Mantle with 30 minutes or an hour, I could teach anyone on this call how to press a button and produce both of these inserts in H13, which is really that value of being able to simplify the process, automate the process, and get something that, like Tammy said, is 70% of the way there with little to no highly skilled labor, which is what West Tech was after. They reduced the lead time they estimated from about 3 weeks because of that backlog down to 5 days. Only 2 hours of active labor time was required from them. Printer land right, lights out over the weekend. And then again, customer actually sought them out here. They won some new business because they were using. One last quote here. Sorry for so many quotes. I love quotes though. But Tammy says about this project, we quickly started the printer on Friday afternoon. No one worked all weekend. We came in on Monday morning and it was done. It took us a few minutes to put it into the furnace. With just a few hours of my team's time, we were able to produce H13 inserts. Mantle's technology is vital for helping us expand since we can increase our tool room throughput for the lights. So just another great example of increasing capacity, making the best use of the labor that they do have, and increasing. Moving over to an example that's not on the molder side, but actually on the toolmaker side from Westminster Tool, who's a toolmaker. They had an OEM who was bringing a new medical device product to market, and they wanted to produce production representative parts ASAP to do some biocompatibility testing and do some prototyping. They were looking to validate the part function, to understand the processing parameters, the actual molding process parameters, and select a final plastic through biocompatibility. This insert, or this part, this is actually just a representative geometry because it was a medical device component. So they weren't able to show the actual part, of course. So we came up with something similar, but the part was incredibly complex. They estimated it did have over 40 swipe by shutoffs as well as a contoured parting line. So with the timeline the customer needed, they were thinking this is going to be a really big challenge for us here at Westminster. The solution was to use Mantle. They printed both the core and cavity here in 145 hours. So that was about 6 days. Again, printing was unattended, less than 2 hours of active time for their team. So they just set up the printer, ran over the weekend, it ran while they were at home, etc. It took 1.5 days in the furnace, or 42 hours in the furnace. And then they did do some quite a bit of finishing work on this tool, just because it was a medical device prototype and they wanted to get all of those features perfect that they needed. But about 2.5 weeks of finishing, about 55 hours of finishing. They squared up the blocks just so they could fit perfectly into the mold base. They hard milled the primary vents. They wire EDM the ejector pin holes. They tap the water lines and pull holes, and then they hard milled just a couple of the difficult swipe pipe shutoff areas to make sure that they were shutting off properly. The result, they were able to produce production representative molded plastic parts for their medical device customer in just 4 weeks. The lead time was reduced by 50%. They estimated it would take them about 8 weeks to do this traditionally. And again, what's probably even more important for them at Westminster Tool was that they saved 65% of the manufacturing and the active manufacturing time compared to traditional. About 110 hours of savings because it only took them that 55 hours that we looked at on this last slide, plus the 2 hours of starting the printer. So much, much less time to produce these inserts from their tooling team. And their tooling team is off focusing on a bunch of other tools throughout the process. They can just do a little bit of finishing work to run these production representative tools, parts for their customer. Here they molded about 7,000 parts with these tools. They're still running great. I think they've gotten a few more orders to produce more of these across an ABS and a PC ABS blend to help their customer understand which resin they want to go to market with. One hitting on this point again, but they actually then ended up winning the production order here, and they're in the process of building a production tool for this customer. They won that order because they were able to do this prototyping work for them. They were able to get them these biocompatibility testings. And what's another kind of added benefit here, what they estimated they saved, or they did save 25% of the time and cost to design the production tool, since they applied all the lessons learned from the mantle tool of all the shutoffs and all the areas there, which is obviously what they're after and a great example. One last example here, one of my favorites, and if you've been following Mantle for a while, you've probably seen it before. I love this example from Nicolay Plastics. It's just a really beautiful insert. I have one here on my desk with me. Again, a lot of EDM work involved to produce the detailed ribs and features that are on this part, which makes it a great use case for Mantle. Here they reduced the lead time from 6 weeks down to 2 weeks. And on the topic of labor, the amount of operations and active operations time from 180 hours down to 12 hours. And the next slide, we'll look at steps that they were able to eliminate and reduce to produce this tool. But here they were molding a nylon glass filled 6.6, 35% glass filled. So a pretty abrasive resin. They ran a few tens of thousands of shots and had no issues. This is actually a component for a emergency vehicle dashboard to help you attach your tablet or laptop to the dashboard for a police car, an ambulance, etc. Looking at the steps they're able to remove, again, common theme here, removing all of those EDM steps from the tool build. And all they had to do was square up the block, finish the ejector pins, and they were shooting parts here. There was actually 3 inserts involved in this build. If you can see on the tool here on the right, you can see the insert on the core on the left, the cavity on the right, and there was actually a venting insert that was placed into that slot inside of here. So they printed 3 tools, printed them all at once. And that took about a week to print those, but of course, again, fully unattended, about a day and a half in the furnace to get them hardened up and into that H13 over 40 HRC. And then they went ahead and did that little bit of finishing work, but from 6 weeks down to 2 weeks, 168 active hours saved. So just a great example of saving lead time, saving active hours. That's the last example I have for you here today. Thanks for sticking with me here for the past 25 minutes, and sorry about a couple of technical difficulties. If you're going to be at MPE next week, please come by and see us. We're going to have all of these applications I just talked about. We're going to have all of the tools in the booth, plus a whole lot more. We're in the South Hall in booth S27055. I have a little map here, but I don't know. It's going to be a little bit of a treasure hunt to find us just because there's so many booths at the show, but we're really looking forward to MPE. So please come by and see us if you're going to be at the show. And thank you very much for joining me. Like I mentioned before, if you have any questions, I'm more than happy to answer them now. You can throw them in the Q&A. You can also always feel free to email me if you want a copy of the slides, you want to look at some of the data, you want to hear more applications. Love to talk to you about your applications. We can quote some parts for you, tell you how long they would take, how much they would cost, etc. But thank you very much for joining me today and giving me 25 minutes out of your day. I'll stick around here for a couple more minutes to see if there's any questions.